In this video, we're going to talk about when a function is increasing, decreasing, or constant, and we're going to talk about relative maximum and relative minimum. Okay? Let's talk about increasing, decreasing, and constant first. All right, so suppose that I is an interval contained within the domain of a function f. F is increasing on this interval if f of x1 is less than f of x2 for all x1 less than x2 on I. In other words, my range values are increasing from left to right. F is decreasing on I if f of x1 is greater than f of x2 for all x1 greater than x2 on I. That's telling me that the range values are decreasing from left to right. And f is constant on I if f of x1 is equal to f of x2 for all xi and x2 on I. Okay? You will use domain values to write when a function is increasing, decreasing, or constant. Okay? All right, so let's take a look at our function here. Let's start with increasing. Okay? So from left to right, my range values are increasing in this interval and in this interval. Now remember, when I write this in interval notation, I want domain values. So starting at -5, but I'm not going to include it. At -5, it's an end value. To -3, I am increasing, but also from -1 to 2. Again, we're looking at domain values. So let's write that up. So from -5 to -3, or -1 to 2. Okay? Now, let's take a look at decreasing. Decreasing is telling me from left to right my range values are getting smaller. Well, there's only one interval for that, and that's this here. So it starts at the domain value of 2, and since it goes on forever to the right, that's going to infinity. So this function is decreasing from 2 to infinity. Remember, the boundary values will always be in parentheses. And then constant, I can show very quickly, that's here. So starting at -3 and stopping at -1, this function is constant. Again, we're looking at domain values. Okay, the last thing I want to take a look at then is what is called a relative maximum or a relative minimum. F of A is a relative maximum of f if there exists an open interval containing A such that f of A is greater than or equal to f of x for all x in the interval. F of B is a relative minimum of f if there exists an open interval containing B such that f of B is less than or equal to f of x for all x in the interval. Okay. Keep in mind, for a relative maximum or a relative minimum value, we are going to be looking at a range value, not a domain value. Okay. All right, so let's take a look at this and determine our relative maximum, and minimums. Okay. Let's start with the maximum. Again, my suggestion might be to see where the function is increasing and then all of a sudden decreasing. Okay. So notice in this particular interval that there is a highest range value in that interval, and that is 0. So there is a relative maximum is 0 at x equal to 0. Remember, the relative maximum or minimum are range values. Okay? Now, for instance, I don't have a relative maximum if I drew a neighborhood like that or put parentheses there. Okay? All right, let's take a look then at the relative minimum. Okay? So my suggestion for this might be, well, where's the function decreasing and then all of a sudden beginning to increase? Okay? That's where I would think about drawing your parentheses or neighborhood for that. So here and here, you can tell in that little neighborhood or in that small interval, there is a smallest range value there, and that is -4. So there is a relative minimum of, or is -4 at x equal to -2. Now, do you see there's another relative minimum? Okay. Here, right? If I draw another set of parentheses there, there is a smallest range value. Well, what is that smallest range value? It's -4. So not only do we have a relative minimum at x equal to -2, we also have one at x equal to 2. And nice for us, that minimum value is exactly the same. In both cases, it is -4.